Hey, what's going on, guys? In this video we are going to see how to use superposition technique to solve these kind of circuits. And the question is asking to find out this voltage at this location and the current at this location. Now to find this one, what we have to do is, first of all, when we have more than one voltage source, we have to separate them and add them as individual voltage sources, right? So here we have 4 voltage separated here and 8 voltage here. So if you notice, first of all, if you notice that everything except this voltage is going to be same, nothing changes except this voltage. And then what we have to do is we have to solve them individually. So first let's start with this one. So first thing what we can do is, when we have parallel resistors, we can combine them together. We can find the equivalent resistance by using this one, R1 times R2 over R1 plus R2. So when we have only 2 resistors, we can use that. Here we have 6 ohm and 3 ohm. So this is going to be 6 times 3 divided by 6 plus 3. And that's going to be equivalent to 18 divided by 9. And that is 2. So we can write this one as 2 ohm right here. So this is going to be 2 ohm. And here we have 4 ohm. And that is connected to this 4 voltage. And others, that's it. After that, this is in series right now. So when we have resistance in series, we can directly add them. So here this is going to be 6 ohm and we have the voltage. So when we have resistance and voltage, we can find the current. V is equal to IR, I is equal to V over R. So we can use that formula. I is equal to V over R. So here we have the voltage, that is 4 voltage, divided by the resistance, 2 plus 4, that's going to be 6. And if you calculate this, that's going to give you 0.667. And after we have the current, we can find the V1, this voltage. This can be calculated by subtracting the voltage drop from this 4 voltage. So 4 minus the voltage drop is going to be 4 times the current through this. We found out the current through that one, that is 0.667 through this one, right? So this is going to be 4 times 0.667, and if you calculate this one, that's going to give you 1.333 voltage. So this is our first, this one, we found out the current and voltage for this one. Now let's go ahead and solve the other one, right? So here exactly same thing. Now here the parallel resistance is going to be this one. We have to avoid this voltage source, so 6 and this 4, right? So this is our parallel resistance. So from this one again, we can simplify this one as 6 times 4 divided by 6 plus 4. So this is going to be 24 divided by 10. And that's going to be 2.4 ohm. So the equivalent resistance is going to be 2.4 ohm. So we can write this one as 2.4 ohm, and we have 3 ohm right here, 3 ohm remaining, and then we have 8 voltage with that one, and that's it. Now we can add them together, like now this is in series, right? So we can directly add them. That's going to be 5.4 ohm, and we have the voltage. So we can do the same approach. We can find the current using I is equal to V over R. And here the current is going to be I is equal to V over R, right? So this should be V over R. So V is 8 voltage divided by 5.4. 8 voltage divided by 5.4, and if you calculate this one, you should get 1.481. So this one gives us 1.481 ampere. So this is 1.481 ampere. After we have the current, again we can use the same approach to find the voltage at this location, V2. So V2 again, this is going to be, we have 8 voltage right here, minus the voltage drop. So here the voltage drop is going to be the voltage, the current through this 3. So 3 times 1.481, and that's going to be equal to 8 minus 4.444, and if you calculate this one, that's going to give you 3.556 voltage. So now we have V2 and V1 and these two currents. Now we can go ahead and find the current through this 6 ohm. So before we do that, we have to find individually, like we have this current and this voltage. Now to find the current through this 6 ohm, we have to first find individually. Now let's go ahead and do that. Okay, at this location we have I total 6 ohm must be equal to IT times 3 divided by 6 plus 3. So this is the equation, like when we have to find 6 ohm, we have to put this one other resistance in stop, right? Because when the current go through this one, it's going to split by these two. So when it go through this, it's going to split through this 3 ohm and 6 ohm. So if you want to find 6, you have to put 3 on top. If you want to find 3, you have to put 6 on top. So that's how this equation works. Now we have this one, and IT is almost, so we found out this total is 2 over 3, right? 4 over 6, that's 2 over 3. Instead of writing 0.667, we can put 2 over 3, and then we can multiply by this, that's going to be 3 over 9. So 3 over 9 is basically 1 over 3. So we can write this one as 1 over 3, and that's going to give us 2 over 9 ampere. So we have found out the current going through 6 ohm for this circuit. Now we can do the same thing for this circuit. I 6 ohm, again this is going to be I total times, we have to look at the, so since we are trying to find 6 ohm, we have to look at the circuit. Okay, this is going through this one and splitting by 4 and 6. So if you want to find 6, you have to put this one on top, 4 on top, right? 4 on top, and then 6 plus 4. And IT we found out 8 over 5.4. So here what we can put the numerical value, that's 1.481 times 4 over 10, that's going to be 0.4, and if you calculate this one, that's going to give you 0.593 ampere. Now we have the 6 ohm ampere for both of them, so we can find the total ampere that's going through this 6. Now to find that one, we just have to add them together, right? So this is going to be I6 ampere, I6 ohm. I6 ohm is going to be 2 over 9 ampere. So 2 over 9, if you calculate that one, that's going to give you 0.222 ampere, and plus we have 0.593 ampere, and if you add them together, that's going to give you 0.815 ampere. So that's the total current that's going through the 6 ohm. So we have found out that one. Now we had the other question was, what is the total voltage? We found out V1, we found out V2, so we can go ahead and solve for the total voltage. So we have to just simply add them together, V1 plus V2, and that's going to be 1.333 plus this one 3.556, and that's going to give us 4.889. And that's how we use superposition technique to solve this kind of circuits. I hope you guys find this video helpful. See you next time.